Okay, so yes, very good evening, everyone. This is going to be the fifth session on the mind chapter. Okay, so let's continue. Let me just give you a quick brief about the previous class. So basically, in the previous class, we discussed about that is a carbonyl amine test, if you remember. Okay, carbonyl amine test. So what was the meaning of this test there? That if you to start with some okay N2 group, that is the primary amine. So basically, this test given positive by the primary amine only. Okay, so let's see that is this is a primary amine. And if in a primary amine, that if you're using a chloroform plus some base there, let's say the QH, so what is happening? This is going to convert into the isocyanide, right? So you can say carbylamine as well, and that's why the name of the test is what? That is the carbylamine test. So this was the last topic of the previous class. So let's continue. Let me just quickly give you an overview what we actually start in the previous classes, right? So we just discussing about the chemical property. Okay, just a quick recap. So we are discussing about the chemical property there, and the chemical properties part we already covered about the amine is like behaving like a base. So as a base part already covered, and now we are discussing as a nucleophilic part. That is if it is behaving like a nucleophile, and in the nucleophilic part that we are discussing already that alkylation, if you remember. Okay, that till then all the hydrogen is combined with the alkyl group, the process keep continue. Okay, so as a nucleophile, and then we already covered the acylation part. There we discuss about that how to the aniline react with the ester ether sorry not ester, and acid, and that is the anhydride part there. And now, previous class, as I only give you a brief in a very first, that is a carbylamine test. So we already covered the carbylamine reaction. Okay, so now in today's class, the next topic of discussion in the same as a nucleophilic part is going to be the that is a reaction with nitrous acid. Okay, reaction with nitrous acid. And then keep continue. Next is the reaction or the substitution reaction is there. Reaction with that sulfonal. It's a very famous test we are going to discuss. So it's a sulfonal chloride is there. Okay, so these are the topic we already covered. Let me just mark it. This part, and this part. The today's class, the topic of discussion is going to be the reaction with nitrous acid. Okay, so let's continue. This is the first topic. Let's start now. So in this part, we're going to discuss about the reaction with nitrous acid. Some portion you already covered if you remember haloalkane and halurene chapter. Okay, so anyway, let me just give you the brief. That is a nitrous acid. So like how the aniline is going to react or amine is going to react with the nitrous acid. So first of all, what is nitrous acid? At least we know about this, right? So what is nitrous acid? You know HNO2. It's not HNO3, that is nitric acid. Okay, so this is nitrous acid. And if we're talking about the structure, how it's look like, that is this is a nitrogen, and then there's a double bond on a nitrogen, and this is the O, and this is a hydrogen. Okay, so if you're observing, there is a 1, 2, and 3, total 3 bond, and the nitrogen does not have any kind of charge. And if you're observing, this oxygen has a lone pair as well. And like same, if we are observing the lone pair again, so this again, that is a lone pair there. Okay, so basically there's a two lone pair and there's a one lone pair. So this is a nitrous acid. And actually for the nitrous acid, how the reaction is going to happen there? This is first of all, it is prepared in situ. Okay, when we're discussing about the nitration process, this is prepared in situ. Okay, so what is the meaning of this word in situ? If you know little bit about the in situ or ex situ processes there, so what is the meaning of this word in situ? That in case of in situ means inside the reaction, we are not using extra. Do you know, we are not using directly the HNO3 HNO2 for the reaction. Actually we are making the HNO3 in a reaction there. That's why the name of the reaction is what? In situ reaction. Okay, so let's continue now that how to go about this. So this is HCl, and then we are having NaNO2. Okay, and just because of this, this become HNO2 plus HCl is NaCl is there. Okay, so if you're observing, like in the very first, we are starting with HCl and NaNO3, and just because of this reaction is going to happen, we're getting HNO2 and NaCl is there. Okay, basically this is the case, NaCl part. So means this is very simple, that in situ means inside the reaction. If we are not using HNO2 directly from outside, so it can be form in a reaction there. Okay, so this is the simple in situ process. Now let's see that is why nitrous acid prepared in situ. Okay, any reason? Because why we are not directly using the nitrous acid? Some reason have to be there, right? So next question be like why? Why? So what is the question? That question is what? Why nitrous acid prepared in situ? Okay, maybe this is the question in your mind. Okay, so let's find out the answer for this, like why it's prepared in situ. So you can say this is N and the double bond and oxygen and again OH. Okay, so basically, do you know that this is not very stable acid? This is not really very stable acid. This is unstable acid. Okay, it means it's quickly form and it is going to be decomposes. Yes. Okay, so let's suppose if this is already that already prepared in a laboratory, and after some time it is decomposes. And no, we don't want decomposes acid, we want fresh acid. Okay, so that's why what is the issue with the direct use? Because the nitrous acid which is already prepared, unstable and already not better for use, so unstable. Okay, wait, because it's unstable, right? I have to write the answer. So because it is unstable, this is not stable, it is unstable acid. Okay, so let's see how the decomposition is there. So I guess you already know that if you are having NO2, it decomposes it into the HNO3. Why? Because HNO3 is a stable acid, and then NO plus water is there. So that's why like quickly form inside the reaction so that it is formed directly and consume an reaction. So that further reaction is not basically possible in this case. Okay, so that's why we are using this. Okay, cool. So that's why we noted that we can't use HNO nitrous acid directly from outside. We prepared in situ in the reaction. Reason is what? Why we are preparing in situ in the reaction? So that is no decomposition take place. Okay. So if you're observing something, the nitrogen here present in plus, that is a 4 and then 3 oxidation state, and this is a plus 5 oxidation state, and this is a plus 2 oxidation state. So from there to there, if you're observing 3 become 5, 3 become 2, this part is the oxidation part, right? And this part is a reduction part. So what is it? It is a nothing. This is a normal, that is a disproportionation reaction. Okay. So just because of the disproportionation, okay, what is happening? We can't use this directly. We are preparing in situ basically in a reaction. Okay. So this is simple. Now let's go. So let's continue with the reaction in the same reaction. Okay, reaction with nitrous acid. We are going to discuss about two method there. So reaction with nitrous acid in the reaction with nitrous acid part, but we are basically discussing that we are discussing about primary aliphatic amines. Okay, and the aromatic amines, or you can say primary aromatic amine. It means again the mean isn't as what, that is only you can say primary amine is going to give the reaction. So it's a primary aromatic amine, and you can say basically it's going to be the aniline there. Okay, generally we can't say like other can't participate, but yeah, general word. So that's why we are using primary aromatic amine. Okay, cool. So let's continue further. That let's talk about this method first of all. That how about the reaction with the primary aliphatic amine? Then we are going with the aromatic amine. So let's discuss about that is the reaction of nitrous acid. Reaction of nitrous acid with what? With primary aliphatic amine. Okay, primary aliphatic amines. So let's go. Let's see how to. Okay, wait a minute. It's amine. Okay, if it is not clear. It's amine. So let's start that how. So first of all, be noted that do you know this preparation require a very small amount of temperature, not very large amount of temperature because it's going to decompose this again. So let's see how that. Let's see the general reaction, and then we are discussing about some important point. Okay, so how about the general reaction? If you are having R NH2, so this is my primary aliphatic amine, right? Let me just write it is a primary aliphatic amine because we are discussing about this part only, right? And then in this case again, as I already told you, we have to prepare in situ. We can't use directly from outside. Okay, so in situ, like we already discussed how to prepare HNO. Not this slide here. Look at this. That how HCl combine with NNO3 and there is a formation of NaCl and plus HNO2. Okay, so this is how. And then do you know actually what is happening? If you remember the previous classes, Sandmeyer or Getterman reaction, okay? So they do you know the benzene diazonium chloride something kind of thing formed there. So yeah, I admit this like the previous cases. First of all, there is a formation of this thing. Okay, Cl is just a counter ion. In term of aromatic compound, we used to call this as a BDC, that is benzene diazonium chloride, if you remember. Okay, otherwise this is aliphatic. Okay, we can't say like benzene. Okay, so like diazonium chloride kind of thing. But do you know this primary aliphatic diazonium chloride is highly unstable. So this is highly unstable. So let me just write that is this is my aliphatic primary aliphatic diazonium primary aliphatic diazonium salt. Okay, and it's really unstable. Okay, let me just write it is unstable. It's not going to stabilize, no. So it's further break, yes. So let's see actually what is happening in the next step, that quickly this bond break. Okay, there is a removal of N2 gas. This is the most commonly asked question in a primary amine reaction with NaNO3 plus HCl, or you can say nitrous acid. What is the side product? NO2 gas or N2 gas? This is really important, okay, like which kind of gas we are having, and plus water as well, okay. Like hydrolysis kind, the water is behaving like this, going to hydrolyze the thing, and we are getting ROH and then plus HCl. So this is how the complete reaction look like. First of all, primary aliphatic amine combined with HNO2, and then there is a formation of aliphatic diazonium salt. Further, it is not stable and going to break. Okay, so this is a general reaction with the aliphatic amine part. Now let's go with the next part, that is, what if I'm using aromatic. Okay, if you want an example for the previous reaction, let me just write the example part as well. So how about the example? Let's see, this is a CH3 and this is a CH2 and this is NH2. And now this is NaNO2 and then plus HCl, and then basically we are getting, this is a CH2. So it's ditto like the previous, the general reaction, and then N triple bond N, and this is a positively charged and this is the Cl negative. Okay, so same, this is our, like, how to give the name, that two carbons, so it's become ethyl, and for this portion only it's become benzene diazonium chloride. Okay, so like that's the same kind of reaction. So this is a benzene diazonium salt. It's not stable as we already discussed, so N2 gets omit, and then if we are using water there, so there is a formation of alcohol. So do you know about this, that if you want to convert a aliphatic amine into alcohol, just go with NaNO3, or let me just write that as a nitrous acid. Okay, again I'm repeating, we can't directly use HNO3 from outside as we already discussed, because it is not going to stabilize. Okay, it is going to break. So that's why we are avoiding the use of direct nitrous acid. We are using the reaction like in which we are forming in situ nitrous acid. Okay, I guess this point is now clear. Okay, so yeah, where are you? Because everyone you joined very late. Okay, anyway, let's continue. So let's continue further. This is all for the reaction. Now, do you know, this is very much important point. If you want to check, in our body we are having protein. If you want to identify like this is a protein or not, how to check it that protein is, like, let's suppose there is some sample and my question to you is this protein or not. So in protein, I guess you already know protein are the amino acids. So amine is obviously present in the acids, or the, sorry, proteins there. So if you want to check the presence of protein, so just go with this test, and if the N2 gets omit, so it means it's confirmed that is the given thing is protein. Okay, let me just write in a form statement. I said that is the quantitative. Okay, if you want to identify that is how much quantity of nitrogen present in acid, so quantitative evolution of N2 is used in estimation estimation of amino acid. If you remember this kind of method where we're detecting the N2 gas, so what was the name of the method? You already know the method name. Anyone, do you know the method name? If you want to detect the presence of nitrogen in a compound or N2 gas, recall 11th class. The detection part. There we discuss about two kind of gases released if the nitrogen present in a compound. One was the NO2. Okay, sorry, ammonia. One was the ammonia and one is the N2 gas there. So if it is released, what is happening? What was the name of the method? That is the Jaldal method. And about this, that is the Dumas method. If you remember, they were applying the N1 P1, sorry, P1 V1 divided by the T1 is equal to P2 V2 divided by T1. They were using aqueous pressure, aqueous tension part, if you remember. Okay, so Dumas method. Okay, this is how we can detect the presence of the nitrogen in a given compound. Okay, it's simple. We already know. Now let's go with the aromatic part. How about the aromatic part here? So let's discuss about the aromatic as well. So in the aromatic part, it's a repeated topic. Okay, recall the previous that is a haloalkane and haloarine chapter. So same ditto mechanism. So let me just write that is how about the reaction of nitrous acid. This is the second part after the reaction of the nitrous acid with the aliphatic amine. So the reaction of nitrous acid, okay, reaction of nitrous acid with primary aromatic amines. So let's see how. Okay. So let's discuss about that. If let's suppose I'm having aniline, everyone you are familiar with the reaction. If you remember the previous class's reaction, right? So it's a NH2 there. Okay. Let's suppose I'm not having this in the very first. Let's suppose I'm starting with the nitrobenzene. Okay. So you know that, for example, if this is my nitrobenzene, so how to convert the stepwise? So first of all, how to generate the aniline? You can use anything. Okay, if you remember, you can use Sn plus HCl, you can use even that is the FeCl, or you can use electrolytic process there. You remember that electrolysis method as well, electrolysis reduction as well. Even you can use H2 and PD as well. Okay, like catalytic hydrogenation. Okay, then, so first step is there is a formation of amines. Okay, although we already discussing about the reaction with the amine, okay, so this is additional step. What if it is not present in a conversion reaction? Okay, so be noted. This is how we are forming a aniline. Preparation part already covered, right? So actual part started from this, and again we are using NaNO2 plus HCl. And then it's really very much important temperature in between 0 to 5 degrees Celsius. Because if there is a little bit change in that temperature, okay, I'm not saying low temperature can be bearable, but the high temperature can't be bearable there. Reason is what? Because decomposite, it's not stable. Yes, after this, what is happening, then that there is a formation of this thing. This thing we already covered so many times. This, okay, that is a chlorine negative. This nitrogen achieve a positive charge here. So what is it? BDC, or let me just write the name of the this compound. It is benzene disonium chloride. Okay, it's a benzene disonium chloride simply. Okay, okay, it's visible. Cool then. So next point is what? Okay, this is the first thing. If the temperature is in between 0 to 5 degrees Celsius, but what if, ma'am, the temperature is increasing? So listen, if the temperature is greater than 5 degrees Celsius, then the reaction followed the same trend as we already covered in the aliphatic part, that there is a formation of phenol. Be noted. This is really very much important reaction. Okay, so be noted. Of temperature greater than 5 degrees Celsius, and you can convert into the Kelvin as well. Okay, so the reaction is not going to be stable, or the product is not going to stable. At that we are end up with, that is phenol. Okay, so phenol is not a new thing. We already know what is phenol, right? That this is how. So this is all for the reaction of the primary amine with that nitrous acid. Okay, so this part I hope it's clear for everyone. Let me just check any question if there. Okay, no. Let's just first talk about the next part. Yes. Now let's see the next thing. Let me just again move toward the chart. Yes, let's back here. So now we just wrap up about this part only. Now let's talk about the reaction with sulfonyl fluoride, and it's one of the famous tests. Okay, that is the Hinsberg method. Okay, so let's discuss about the reaction with sulfonyl chloride. I'm repeating again, it's really very much important method. So let's discuss about that is a reaction. So we are discussing about when amine act like a nucleophile, and in that part we're discussing about reaction with sulfonyl chloride. I hope everyone you know what is sulfonyl chloride. If you don't know, so just go check it. So sulfonyl chloride. Everyone you know sulfonic acid. So how the sulfonic acid look like? If let's suppose this is our benzene, and okay, this is how it's look like. And if you to switch that OH, you know, this is the sulfonic acid. If you to switch, you know, carboxylic acid and carbonyl chloride. So same in this, if I am switching this OH with some halogen group, chlorine group, right? So it's become sulfonyl chloride. So like be noted. What is the reagent we are using? That is a sulfonyl chloride. Okay, so let's go that how it's going to work, and that's it. So in this case, this method basically known as a, okay, let me just write properly, let what is the connection with this reagent. Okay, let me just write the name of the method. Okay, so this is very famous test, that is a Hinsberg method. Okay, this method basically used for the detection of primary amine, secondary amine, or a tertiary amine. If you remember, that is a Lucas method and a Victor Meyer test for the detection of primary alcohol, secondary alcohol, and tertiary alcohol. Same like this method is important for the detection of whether the primary amine present, secondary amine present, or tertiary amine present. Okay, so it's a Hinsberg method. And like this is the actual name of the method, and this is actually famous for this name. But like that if I have to write the statement, so how it's look like, that is the same reaction with sulfonyl chloride. Okay, like actually this is the complete name. Otherwise, this is famous for the Hinsberg test. So let's see how it is going to react. So let's discuss all the points as we're discussing about primary, secondary. So in this part, we're going to discuss about the reaction with primary amine. Okay, wait. Let me just first write about the test. So this test used to distinguish between primary amine, secondary amine, and tertiary amine. Okay, so let's see how, right? This is important and how it is going to react. So let's continue about the test, how it is going to work. So let me just back here. Okay, like this is how it's look like. Collect all the information, sulfonyl chloride, and let's first talk about the reaction with primary amine. Okay, how it is going to react with the primary amine. Let me just change the position of this. Okay, here. This is how it's look like, and now we're discussing about the reaction with primary amine. So let's go with this reaction with primary amine. Okay, so just think about it. Let's suppose I'm having a primary amine. Okay, this is my primary amine. Nitrogen has a lone pair, right? And okay, let me just write like this. This is SO. Okay, and this is chloride. So just treated this sulfonyl chloride like a carboxylic acid. Right now we already covered so many reactions with the RNH2 and then CO part here. So nitrogen has a lone pair. So nitrogen will be like, okay, I am reacting here, and see this. This bond has a choice. This bond open up. Okay, so this is the reaction. This is how the reaction look like. Don't worry, I will tell you the shortcut as well, but just try to understand actually how the reaction is going on, right? So the nitrogen has a lone pair, and this is how the reaction is going on. And let's see what is going to happen. That you can change the position. It's not like it's fixed, okay? So I just want to explain the mechanism. You can change the position of the benzene. It's totally up to you. So how it's look like? That is oxygen, negative charge, double bond. Okay, chlorine still there, and this nitrogen, hydrogen, and positive charge. And R is still connected here. Next step, let's discuss about the next step. What is the next step? Oxygen back, chlorine leave. Okay, like every time. I can so in a single step be like this is how, and the chlorine kicked out. Totally. Your choice. Otherwise, you can separate the mechanism as well. So this is how it's basically look like. Okay. Now, in this case, next step is what? That is chlorine is already leave. Okay. I guess it's not visible. Hmm. So chlorine is already leave. Okay. Now we're left with that. Wait. This is benzene. This is sulfur, oxygen, oxygen, nitrogen, R, and still there is a two hydrogen present. Okay, like this. So next step is what? What is happening? Okay, so actually what is really happening? I just want to explain the mechanism. So this is chlorine. Chlorine like hydrogen just come with me. Actually it's a single step, that is chlorine attack on one hydrogen directly. Okay, or abstract. Let me just write how. Let me just change the position of the hydrogen. Okay, so these two things combine. Okay, so actually the chlorine is going to leave. Okay, I hope this point is now clear for you. Okay, let me just remove and let me just write HCl. So HCl release, and now this is the first point. If you're observing something, what is the complete game? The complete game From there to there, let me just observe, or you also have to observe this. Look at this. Two hydrogen, it become one hydrogen only. It means hydrogen, the basic criteria for the reaction with sulfonyl chloride. Okay, point number one. It's a primary amine. Primary amine. Okay, let's go with the reaction with the secondary amine. Okay, so let's go with the secondary amine. Okay, same ditto. Now let me just write, this is some R1 and this is nitrogen. Nitrogen has a lone pair and this is R2. Cool. Okay, same sulfonyl chloride. Just try to observe the reaction. It's very simple. Okay, I know it's an amine type of reaction. Maybe it's difficult. No, it's easy. It's actually really very easy. So it's a SO and this is chlorine. This time I'm not going to explain the complete mechanism. Just observe that what is happening. These two combine. Okay. As I already told you, we're going to discuss about the shortcut there. So what is the shortcut? These two combine. Directly HCl remove. Okay, directly HCl remove and then HCl and okay, that nitrogen combined with sulfur, double bond, SO. Wait. Okay, so like this, and this is some R and this is some R2. I guess something maybe strike in your mind again that from there to there there's a two hydrogen. Now it's become zero hydrogen. The previous one two hydrogen become one and now two become single zero. Now let's see the third case. Let's discuss about the third case, that if there's a tertiary amine. So what is really happening? R1 nitrogen, R2, and this is some R3. Nitrogen has a lone pair. But this time, that how the chlorine is going to react, because in this case, no hydrogen present on a nitrogen. Okay, so it means that if in the same reagent, if I'm using in the same reaction there, so what is happening? No reaction. So means that make sure what is the first point we are noting from here, that if the amine want to react with the sulfonyl chloride, so at least one hydrogen have to be there. Okay, it means no reaction. It can't react. So the point number one. So there is a no reaction. No, that's it. So if you want to check between primary and secondary and tertiary amine, so the two thing primary and secondary going to react with this, okay, and there is a complex formation. But in the last case, no reaction have to be there. Okay, first point. Now the second point, but how to differentiate between primary and secondary, because both are reacted with the sulfonyl chloride, right? So now we have to run the second test. Let me repeat one more time. For the primary amine, secondary amine, tertiary amine detection, I'm using the sulfonyl chloride. So in the first one, if I'm using sulfonyl chloride, react. Second, react. Tertiary, no reaction. So third is already out of the race. Now let's talk about the next reason, that how to differentiate between primary, sorry, and secondary amine. Okay, now that in both the cases, if I'm talking about the primary amine part here, so what is really happening there, that is, this is the benzene basically. Okay, this is the benzene basically. And okay, let me just write the thing be like this. This is SO and this is this and this is nitrogen and this is some R. This is how it's look like. And how about the secondary amine? If we are discussing about the secondary amine there, that again like this, and this is SO and a double bond and a nitrogen, and this is some R and this is some R2. So if somehow we are able to manage the presence of the hydrogen in this case, and this case there is no hydrogen. I'm repeating one more time. In primary amine, when sulfonyl chloride react with amine, nitrogen still has one hydrogen left. Okay? But in the secondary amine, no hydrogen is present there. So if in the case number one, I'm using a base, we can use base, it's acidic hydrogen. So if I'm using a base, that is KOH is a base. It's acidic proton. So be noted, once if you are using KOH, so primary amine is soluble. Okay, it is soluble in KOH. Okay, but if you are observing this, that if I'm using the KOH in this case, it is insoluble. Okay, why it is insoluble? Because in this case be like, how to extract the proton? The proton is not present there. Okay, so what is the brief of the Hinsberg test? That if you're using primary, secondary, or tertiary amine, tertiary, no reaction, and primary and secondary reaction there. And then if primary amine is present, primary amine soluble in base. You can use NaOH, you can use KOH as well. But secondary amine, insoluble. This is how we are able to differentiate between primary and secondary amine. Okay, I hope this point is clear. Now let me quickly brief that what was the main point about the test. So listen, my dear student, that is what is the first point. You know how the question frame, how to differentiate between primary, secondary, or tertiary amine. The point number one. So listen that if you want to distinguish between primary, secondary, or tertiary amine, so primary amine test give carbalamine test positive. Okay, positive. Second test we just discussed, that is a Hinsberg test positive. Okay, positive. Now one more, that is soluble in QH. Okay, this is the basic point. And if you're observing that is secondary amine or tertiary amine, both can't give any test with the carbylamine. Okay, carbylamine, be noted. So this is how we're able to distinguish between primary, secondary, and tertiary. If further you want to separate the secondary from a tertiary, then go with the Hinsberg again, and then it is insoluble in QH. Okay, so how the question asked in a paper that there is some compound A, and if you have to use the Hinsberg reagent, that it is insoluble in QH. So what is the first thing should be strike in your mind at that point of time? That is a secondary amine. Okay, so this is how the test work in the organic chemistry. I hope this point is clear for you. Okay, okay, Arul. So that's it. This is all for the test. Now, okay, let's solve a question. I hope the test is clear for you, right? Okay, okay. Let me just write the question. This is a PYQ of amine. Okay, main. So this is a question. An organic compound A on treatment, organic compound A on treatment with benzene. Okay, sulfonyl chloride. Hmm. Benzyl sulfonyl chloride gives some compound B. Okay, now you have to identify what was the B. Wait for second statement B. And the next one is what? B is soluble. B is soluble in diluted. B is soluble in diluted NaOH. Okay, solution. So you have to identify what is A. Okay, this is the question. That what is A? So options are option number A, if it is not a okay, let me repeat the statement. An organic compound A on treatment with benzene, sulfonyl chloride gives some compound B and that B is soluble in diluted NaOH. Okay, so just by observing the statement, one thing I know, like what will be the answer maybe. So let me just write the option. This is C6H5, it means benzene. Okay, and this is NH, CH2 and CH3. Option B, C6H5, CH, NH2, and this is CH3. Okay, option C, C6H5 nitrogen, CH3 twice, and option number D, that is C6H5 and CH2 nitrogen and CH3. Yes, please. What is the correct answer for the question? This is not difficult question. Please answer the question. Okay, I'm waiting 1 minute for you. Time start now. Okay, Arul. Actually, in this question, the point is what? Okay, I guess already know the answer. Okay, Niharika. Primary amine. Yes, very good, Arul. Right? So, good, everyone. So, option B is the correct here, right? So, answer is what? You know, the soluble is the important point here. So, primary amine, it is secondary amine, right? It is tertiary amine. It's what? Primary amine. Okay, wait. Actually, this is primary amine. So, it's a primary amine. Test positive. It's what? It's a secondary amine again. So soluble means primary amine and hence option B is the correct. Okay, so this is how the answer B is the correct answer here. Okay, so let's see the next point. Okay, so now we finish with the reaction as a nucleophile. Okay, let me just again go with the chart where we're discussing about all the point here. This part is done. Now let's see the third chemical property, that is electrophilic substitution reaction. That our favorite reaction, you know, nitration, that alkylation, acylation, that part. So electrophilic substitution reaction. Okay, if we discuss about exception in the organic chemistry in electrophilic substitution reaction, so yes, this is the point. Aniline have exceptions. So let's go how. So let's start with the reactions. Electrophilic substitution reactions. Okay, I'm sorry for this. So let's go again. We are discussing about this. So let me just write all the step now. One is the bromination. Second is the nitration. Third is the sulfonation. And the last is the Friedel-Crafts. And if we're discussing about the important one, although all are important, but you know, important one. Friedel-Crafts, the same as acylation, alkylation part. This is important. This is important. Two are very much important. So let's start with all three, all four, one by one. Let's discuss about bromination. I have to simply write the reaction only. Mechanism you already know from the previous classes, so let's not waste our time. So let's discuss about the bromination of aniline. Bromination of aniline. Okay. Okay, so in this we are using Br2. And if you remember the reaction with the phenol, you know, we are using bromine water. If you're using bromine water, there was a two reaction. If you're using some non-polar reagent, only one position, okay? Only one position is connected with the NO. Okay? Just wait, Arul, I will tell you. Wait, wait. Okay, so bromination. And if you want to knot it, just go with the nitration. If you want to maintain your knot, so in this case, we are dealing with the exception. Okay, if you want to knot it only. So that's it. Again, bromine water test. And there's a two thing. If you're using bromine with water, so all position is occupied by the bromine because bromine is really reactive now. Right? So same like the phenol reaction. If you are using plain aniline, okay, means aniline, I will tell you why I'm using plain word because protection part we also covered here. So it's a BR2. So BR combine everywhere. Like it's become 2, 4, 6. Okay, 2, 4, 6, 2, 4, 6 try bromo aniline. Or how about the PPT? It's a white PPT. If you remember the previous one, I guess there's a yellowish whitish PPT, and in this case, there's a white color PPT. So in this case, now the question will be like why? Anyone, can you just tell me that why the bromine combine at every position? I guess I already told you this part in the alcohol part as well. That why if I'm using water and bromine connected at every position instead of one. I explained this topic in the phenol in very much detail if you remember the point. Yes, please. What is the reason? Okay, due to water. Okay, anyway, I know it's water is present there. Wait, Arul, let me just let me just ask one more question to you. Okay, maybe you're getting. Let's suppose, do you know that in this case, if I'm using NO2, okay, and I'm using the same bromine, okay, so this is meta directing. So my bromine is connected here. Okay, means I want to highlight to you, we can't get this product. Only one bromine. Only one bromine. Okay, bromine water, okay, you can say, ma'am, because you are using water and it's very reactive. But again, why all three position? Okay, maybe you are getting little bit my point. Everyone. Okay, so let me give you a hint. The name of the reaction is electrophilic substitution reaction. Was the reagent here? Was the attacking reagent here? Electrophile. So, Arul, can you just tell me between nitrobenzene and aniline, if electrophile want to select something, so which one is a better nucleophile here? I'm repeating my question one more time. If I give you a choice about aniline or a nitrobenzene, so which one is a better nucleophile for electrophilic attack? Okay, there's a two plus point. One is a water. And the second plus point, do you know NO2? It is a lone pair present on NO2. And just because of the presence of NO, means main point is what? If I'm using a normal benzene and if I'm using the same bromine, so that only one position is occupied by the bromine, if you remember, only one. Whether you can go with water or you can use any non-polar solvent. But the question will like why? What is so special about the aniline that we are getting three position occupied by the bromine? So answer is very simple. That is donating group. Okay. Maybe you want to say, ma'am, that was withdrawing, right? So in this case, what is the point? That nitrogen has a lone pair and they are moving toward the benzene ring. So it activate the benzene ring. So it means more Jaeger for the tech. So bromine, but what is the already plus point here? That is this water. And the second plus point is what? That it's a activating group. NO2 is the activating group. It is that is electron rich center. So hence bromine occupied all the position. Okay, so is this point clear for you that water is the plus point, but still that correct answer for the question be like N2 is electron donating group, activating group. Okay, I hope this question is now clear for you. Bromination of aniline. Now let's see the second thing. After bromination, next one, let me just check the chart. Nitration, right? Okay, so let's just first finish let activating part we're discussing, right? So wait, so that we can explain, we can understand two point. First of all, highlight this point. This is activating group. Activating group. And now, recall. Uh, but about NO2. Okay. So, Arul, that is in the first case, the NH2 is there. In the second case, NO2 is there. Okay. If bromine is a electrophile, it is waiting. Bromine is positively charged, right? So, in this case, first of all, bromine prefer. If I'm selecting between A and B, so bromine prefer the A. Why? Because it is electron donating group, and if you're observing, this is electron withdrawing group. Okay, the point number one. And if with the bromine, if I'm using water as well, so bromine combine at three position, all the three position. Reason is what? Because it's a activating group. Okay, so is this point clear, rule that if the same bromine water combined with NO, so only one position is occupied by the bromine, not all the preferable position. Because NO2 is automatically a deactivating group. It deactivated the benzene for the electrophilic reactions. Is this point clear, Arul? That why bromine combined at all the position? Because the activating, just because of the activating nature of NH2 group. Please confirm it is still not clear. Okay, good then. Okay, so yeah, we are discussing about the protection part. NH2. So let's discuss about this. We'd use NH2 as a activating, but how much activating? It's highly activating group. Do you know sometimes side reaction can be there? Recall the limitation of the Friedel-Crafts alkylation if you're using aniline. So what was the problem with the aniline? Aniline itself combined with the electrophile. Let me just explain what I want to explain to you here, that if I am using aniline, okay, if I am using aniline, and let's suppose the some electrophilic reaction we are using, so electrophile be like, why I have to go with benzene? Benzene is aromatic. Benzene will be like, why I can't take you electrophile? Then electrophile is a better choice. Electrophile be like, why I have to bear the tantrum of the benzene if I'm already having an NH2 group, right? So electrophile simply combine with this. So it's a problematic. It's that much activating that sometime it also react with the electrophiles. Okay, and it's problematic. So means we have to sometime overcome this. Yes, we have to overcome this. And it's a one of the famous point, and it is only present in an aniline, that is protection, that we have to protect this. Problem is what? That NH2 lone pair is very activating. Maybe this question come in your mind, ma'am, but why not in a phenol? That why this problem we are not facing during the reaction with the phenol? Because there we just simply discuss about bromine water test, and you are not highlighting these points. Because listen, my dear, that is in this case, oxygen has a lone pair. In this case, nitrogen has a lone pair, and everyone that is nitrogen is a good donor over the why? Because nitrogen less electronegative, so it is a very good donor as compared to the oxygen part here. Okay, first point, that phenol not that much activating as this aniline, or you can say amine does. Okay, so we have to protect. So that electrophile main focus only on benzene, not on the aniline. So let's see, let's discuss about the protection part. Okay, so this is another topic, that is protection of aniline. Protection of aniline. Okay, how to protect? That you can use anything. Okay, let me just write three protecting reason. You can use R, COCl, even you can use R, CO, OR, even you can use R, CO, and CO. So it be like that is the chemical property repeating here. Remember that what was the case here, that if you're using HCl part, so hydrogen combine. So first of all, what is happening, that let me just write, it is a aniline. Okay, nitrogen, it is protected now, hydrogen with a CO, R part, it's protected now. Or now next thing is what, in the point number one the side product is what, HCl. Okay, in the point number two we already covered this topic earlier, so okay, if you remember. And in the second point, that is the side product is the ROH, and in the third case the side product is the RCOH. Okay, and we already covered that we are using this method over other method. What is the point, or what is the reason here? Because in this case you can use pyridine, and the reaction rate can be increases. We already covered every point. So that's why this is the most probable group for the acetylation. So protection of aniline or protection of amine is nothing. Aniline we are going to prefer, right? So aniline is actually acetylation process. So let me just write ace, wait, acetylation of aniline. So if maybe in book sometime protection is not there, so maybe it will be there. Okay, so both are okay. Acetylation or protection of aniline. The point number one, we have to protect this. Be like, ma'am, see, but Isn't it we are changing the that NH2CO part into the other thing? Let me just give you a kind of brief that it is a plus M group. Everyone it's a plus M group, and it is ortho and para-directing. Ortho and para-directing. And now it's your turn. Can you just tell me what is it? Is it activating or deactivating? Like ortho directing, para directing, meta directing. Anyone? There's a two changes. The change number one, lone pair now not that much available for the bonding. I will explain this, but anyone, that is it plus M or minus M group? Meta, very good, Arul. Okay, so listen my point that how it's meta directing. This is a aniline, right? The problem is what? Aniline itself combined with the electrophile, right? Now the problem is solved that after the protection, what is happening? Okay, so look at this. That in this case, nitrogen lone pair, nitrogen lone pair. So in this case, nitrogen has only one choice to add the benzene. It's 100% donation. Okay, it's 100% donation. Okay, second point that in this case, look at this. It's a 50%, and in this case, look at this. It's a 50%. Did you notice something? That is the nitrogen lone pair splitted. Okay, nitrogen lone pair splitted here. The point number one. Now, next question for you. Look at this. In this case, like this is moving. And now, Arul or everyone, just let me know A, B, or C. Same question. Okay, Arul, same question. Please let me know that I guess number is not visible. Okay, it's visible B. So can you just tell me B? What do you want? Meta or like ortho or para position here? Hmm? No, no, no. Hindrance is not the part here. Okay. Hindrance is not going to affect meta and ortho and no, it's not the case. I'm asking to a question that it's meta directing, ortho directing, or para directing. Okay, maybe next question be like, ma'am, after protection it's become minus M, isn't the complete direction is different? Hmm? So listen, my first point. We are simply protecting the H2. We are simply reducing the density. If you're knotting between, if you're knotting between A and B, in A, 100% electron moving toward the benzene, but in the second one, that we are smartly tackle the problem. How to? That is the 50% this side and 50% this side. What is it? If you remember the 11th class topic, it is cross conjugation. That if the same group participate in two type of conjugation, let me just divide this into the two half. That look at this, it's a cross conjugation, half this side and half that side. It means from A to B, the electron density reduces. How much? 50%. But still, all the electron density become 50, but still it's moving toward the benzene ring. Okay, Arul. So still it's a ortho para directing. It's not meta directing. And try to understand the difference. This is my minus M. It's meta directing. Okay, but ma'am, isn't it this is same? No, it's not same. Here the CO part connected. So it's what? It's our amide group. And what is it? It's our imine group. Okay, this is little bit difference, I know, but still it's a different. Okay, is this point clear, Arul? That it's a like meta and which directing. So if lone pair, although little bit, but still residing over the benzene. Recall the most electronegative group, halogen family. They have lone pair just because of that. They're a very good plus M group, right? I know minus side dominating, but still ortho and para directing. Arul, this point clear? That still it is a ortho para directing. Okay, and hindrance not playing important role here. Okay, so that's it. So after this, if you are using 50% electron density, so now this is not that much deactivating. Now if you are using electrophile, so electrophile be like Now electron density is not that much high. So let me just combine either a ortho position, okay, like this and this. Now some of you like, ma'am, isn't it the protection differentiate the molecule? Okay, we don't want this. You can deprotect. Okay, first of all, we're protecting. Do the reaction, then deprotect. Okay, how to deprotect there? Add some base, any base you can use. Okay, so you can use any base. So what is happening after the base or hydrolysis step, you can say. Okay, what is happening? This is going to remove. Okay, we are just left with NH2 part only. So again, we are just left with aniline. Okay, so again, protection, deprotection, and this is the last point. Let me just check any point I missed or not. Okay, that's it. Deprotection, let me just write it here. Mhm. Deprotection, okay? At that, we are ended with this product. Oh, I missed the, I will, wait, Arul. And still, this electrophile, there's a two product, one is ortho and one is meta. Sorry, I said meta, I'm sorry. Ortho have to be there. Okay, same. Okay, this is how. Let me just explain one more time. Listen, everyone. What is the problem that if I am using only aniline, okay, so in this case, 100% electron moving toward the benzene, okay, so let me just write that is you can say 100%. So what was the problem? That the point number one, electrophile connected here, electrophile connected here, even electrophile connected here, okay, and plus that is the electrophile also connected here. Why? Because electron rich. Okay, but we don't want these things. We want that. What if I don't want this product? I just want only this kind of product in aniline. So only either this or this. Okay, this is the point. I just want these two product, not this product. Or we just discuss bromine water test. We want bromine connected only to at two positions. Then how to go? So in this case, we are protecting this. How to protect this? That in order to protect this, we are using any acetyl group. Let me just use our COCl group. So what is happening? That this hydrogen and this chlorine both combine and there is a removal of HCl. So HCl basically omit. Okay. Next step that in this case now we are end up with this is N hydrogen COCH3. Okay. So this is how it's formed. Now look at this, that nitrogen has a lone pair, some lone pair transfer here and some here as well. Okay, because there's a two kind of resonance. So let me quickly give you a brief about the cross conjugation. Let's just suppose if you are having a double bond here and this is double bond. So it's a 11th class topic. It's a cross conjugation. Okay, it is a cross conjugation. So if it is participating here, this bond open, the point number one, or the point number two, maybe this bond is also participating, noting something that this O is in separate conjugation with this side group or this side group. So 50-50. So same here, let me just back again. Look at this. If you are observing this, look at this. That is a 50-50. Some lone pair transfer here and some lone pair transfer here. Okay. So still nitrogen transferring the electron to the benzene ring like the aniline. But what is the plus point in this case? The plus point is in this case that is 50%. Differentiate 50 toward the CO side, 50 toward the benzene side. So what is the problem in the very end? It's highly activating group. Okay. Let me just write what is the issue with the aniline. It's a highly activating group. Okay. Now this is less activating. Why? Because it's 50% only. Okay, the point number one. Now, in this case again, you have to go. Okay, let me just write this part only. Okay, here. So we are using protecting aniline. Okay, so see, let me just use again. This is bromine and water. Okay, so what is the difference? That maybe the bromine connected here. Okay, because we reduces the electron density. As I already told you what was the reason behind that is why the bromine connected all three position because the aniline is highly activating. Okay, NCO and the CH3, let's say. Okay, next step, that after once we are getting what we want, that deprotect this because this is extra point. Okay, this is just a protection. What is the meaning of protection? You have to protect something by some dilemma, and once the problem solved, that is you have to deprotect. Okay, that let's suppose we are having exam, we keep studying. It's not like every time we keep studying, right? There's a some particular point, protection, backup plan. So it's just a backup. After once the problem solved, remove that. Okay, so the next step is what? That is deprotection. Then question will like, ma'am, how to deprotect? You can use any acid, or let me just write that is you can use acid, and even we can use base for the protection. Most commonly we're using bases. Okay, so it's a deprotection. So after the deprotection, what is happening? That aniline restored, that the deprotection only combined here or work here. NH2 restored and bromine plus NH2 here and bromine. See, the problem solved. Okay, so if in a lab we are having bromine water only and we want to convert the like aniline directly into ortho and para position, sorry, ortho bromine and para bromine aniline, so we can go with the protection part. Okay, so is this point clear to you now, Arul? That what was the point? Just let me know. Otherwise, I can explain one more time. Okay, the problem solved. That actually how actually what we are doing here. Please respond if you are there. Otherwise, let's continue. Okay, good. So that's it. This is all for the protection part. Okay, now, so this part is done now. Now let's see the next method, okay? So bromination part we already covered, nitration. So it's an exception as I already told you. So how about the nitration? So first of all, it is NH2 group. The one thing should be very clear in everyone's mind, that's the problem with NH2, because activating. Anyway, so in this case, if I'm using, the nitration reagent HNO3 and H2SO4 we are using, okay? So technically, what is it? Ma'am, it's a plus M group, right? It's a ortho and para-directing group. Okay. So then that this is NH2 group and with respect to this NO group connected here. Okay. Next, this is NH2 and this is NO2. Okay. It's obvious. So what is it? It's a ortho and it's a para. So my question to you, yes, please. Can you just tell me which one is the major here? Wait, Shiva. Anyone? Which of the following is a major product here? Ortho or para? What if we get ortho Brahmin as a major? No, it can't be possible technically for the Brahmin. Bromine is not small group. You can go with the chlorine, but bromine no, can't possible because bromine is bulky group. So we have to prefer every time ortho. For aniline, it's not possible. Chlorine, it can be, but no, for bromine, it's no. Ortho is the major. So I'm asking, so you are saying ortho. Any reason? Hmm? Arul? Any reason? Okay, if you're claiming something, at least you know the answer, right? Or sorry, reason. Ortho or para? So you said ortho, but why? Para? Okay. Hydrogen bonding. Hmm. You can say hydrogen bonding, but I already told you it's exception. So something is not okay here, right? Wait, wait. There's a twist in a story. So what is the twist? NH2 and NO. But no, it's a meta position and it's a plus M group. How it is possible? Okay, okay, wait. So it's my meta. Let me just remove this. Okay, it's ortho, it's para, and it's meta. Now let's see the percentage, and it's like problematic. Let me just give you how let's look like. So it's a 2%, and ortho is only 2%. But why? Why this is the problem? No, Shiva, still para is the major. But question be like, but if you're comparing between a A or a B, okay? No, Shiva. You are asking about that is any method synthesis. Listen, my point that we can get orthobromelain. Okay, but percent is a little bit different. Okay, the difference is not that much high that I'm getting bromelain only 1% and that another one is 98%. Okay, that major minor like let's suppose one is 47 and the other can be 52. It's not different. It's not that much problematic. Okay, Shiva. So it's not like I'm not getting ortho only. 51247 means. Okay, maybe you're saying it's I don't know what is your what is your point. Okay, like for which you are mentioning. Okay, my question to you that okay, we can say between ortho and meta, it's maybe understood, but why meta is maximum? Like, isn't it plus M? Isn't it ortho and para? But why? Why 47 meta? This is a potential question from this, and it's already asked an advanced question and so many time in a mean as well. Why this? No, it's not ask, ma'am. No, I guess in a group, some student posed a question. There is a some no, nitrophenol, add some that NNO3, and there's a A, B, and C formed. Okay, so check this question in advance. This question was definitely there. Anyway, let's see how. Question that, ma'am, why? Why meta? So, why meta 47? Let's try to find out the answer for this. So, first of all, as we just discussed, that aniline is activating. We are using HNO3. You know, HNO3 is not that much weak acid, strong acid, very much strong acid. So HNO be like, I am acid. You know, I already told you this thing so many times. If in a organic chemistry, there is a choice of a acid base reaction. It is more preferable over any electrophilic reaction, nucleophilic reaction, cyclic reaction, pericyclic reaction, or any decomposition. Be noted, it's really important. HNO be like, if already NH2 there, if already base there, then why I have to use my energy on benzene? Okay, so what is the point number one? That in this case, that HNO is an acid and this is a base. So what is happening? Acid base reaction. Yes, acid base reaction. So means next point is what? That this is N, hydrogen, hydrogen, and hydrogen. Okay, base behaving like a base, abstracting the proton from the acid, and this. Good. Okay, so what is this? This be like I m plus m and ortho and para position, because this be like no, I am a side product. And yes, can you just tell me, is it electron, is it activating or deactivating? Yes, Shiva. Okay, here, I don't know. No, it's blur. Hello, am I audible? Please confirm. Actually, I guess video was stop. Are you able to hear me? Repeat the question. Okay, I will. I will. Listen my question. My question to you, that if I am using aniline, okay, it is a plus M group, it is ortho-para-directing. Okay, Arul? So technically, that in this case, if I am using NH2 or NO2 and the plus NH2 and NO2. Okay, my first question was that between this, okay, this is ortho, this is para. So my question was that was the major one, right? So means, every time we used to observe like para, anti to one another. So this is a major part, right? So it's a major part, and this is minor part. Sorted? Like technically, if we want to explain the question apart from hydrogen bonding and that concept, right? Minor and major, para because anti. So, okay, that's it. This is expected answer from everyone. But in this case, let me tell you one thing. If I am go with the same reaction, nitration part here. So in this case, there's a one more product we are getting. The product is what? That NO2 also connected at meta position. The point number one. Okay, and it's not like that very much minor product. No, it's not that much minor. So if you to go with ortho, sorry, this part. So this is the first one. Ortho 2% only, para 51%, and meta 47%. The first question, that why meta product? Second question, not a trace, it's a 50 40, sorry, it's a 47%. And if you are comparing that group wise, ortho para more preferable. We can explain, ma'am, somehow there is some problem that maybe we're getting meta, but it's not maybe problem, it's 47% yield. And the second question, why 2% only? Okay, so Arul, question be like that why in aniline we are getting 47% meta product? Okay, is this point clear? Please confirm, Arul, that why meta and why 47? Okay, this is my question basically. So let's go again what we're discussing here. So base, okay, if base NH2 is a base and HNO3 is acid. So as we know in organic chemistry, that if we are having a choice for acid base reaction, so acid combined with the base and normal reaction have to be there. And now in this case, just because of the presence of positive charge on nitrogen, it is behaving like a deactivating group. It is behaving like a beta directing group. Okay, it is being like a meta directing group. Okay, so in this case, just because of this extra reaction here, if again you have to go with the HNO3 plus the same thing, that is H2SO4, so this prefer now meta position only. Okay, meta position, and meta position is not that much small amount, that is very much high amount is there. Okay, so that's it. I'm repeating my explanation one more time. In aniline, HNO3 is there. It combined with the nitrogen lone pair, form the ammonium ion, and behaving like a deactivating group, behaving like a meta-directing group, and that's why nitrogen present at a meta position. Okay, meta-directing. Yes, you can say deactivating group. Okay, meta-directing. Is this point clear now? Okay, I guess you already know activating, deactivating group. When negative charge, activating. When positive charge, deactivating. Okay, sorted? So that's why. Okay, I guess nitrogen part is covered and exception part is this only. And like if you want to write in a reaction, this is our conjugate base, you know. Sorry. Wait. Okay, I'm erasing this, okay. This is our conjugate acid. And this is our base. Normally, you know, conjugated reaction kind of thing is going on. Okay, I hope this question is clear for you. Yes, please, if you're not able to understand this, let me know. Okay, I guess it's enough. So much time already, right? Let me just finish the last point. Okay, is the question clear for everyone? Okay, okay, Arul, listen. You're right. Okay, it's not like meta is a measure product. Are you getting this point, Arul? It's not like meta is a measure. Meta is still 47. Major is the para. You know, still the dominating part is H2SO4 you are saying. Still the dominating part is ortho and para. Still the para is the major. Okay, but the problem was that why meta is 47? Because still you can use H2SO4 or you can use HNO3. Both before the generation of electrophile, they are very good acid. You know, H2SO4 even strong acid over the HNO3. So H2SO4 is not problematic part for the generation of ammonium ion. Okay, so that parast is major. Okay, but question is what that why meta is 47%. Okay, so answer because first acid base reaction is also there and not that much small part, it's 47 part. Okay, Rul, just let me know, is it clear or not? Okay, second point. But ma'am, how to overcome? We do not don't want this. Same, recall the protection. So if you want that meta part does not have to be there. Just go with the protection. So if the same reaction, if this is my aniline, if the same reaction in the same reaction, first of all, let's go with the protection part. Okay, as we already discussed. Okay, it's still remove. That's where discussing protection first. Again, we are protecting this. Now, the problem solved. What was the problem? That nitrogen combined with hydrogen. Now, the base acid be like, you want to give the hydrogen? Nitrogen be like, no, right now I'm not that much electron rich. I'm not that much strong base. Because now I am connected with the electron withdrawing group. So basicity reduce. Acid base reaction automatically you can say omitted here. So now you can go with the nitration simply. Okay, if you are using HNO3 plus HNO3 and H2SO4, so what is the change? Let's see what is the change in a product formation. See the beauty. Okay, that's why this is organic chemistry. So it's a OR and a NO2, and now it's become 90%. Earlier 51%, now it's 90%. And still, okay, although ortho still not that much manageable, 10% only, but main agenda was para, major. Okay, we're just increasing the yield of the product. They're 51% and now it's become 90%. Okay, and okay, nitro is still there. Second step, last step, deprotection again. Okay, as I already told you, our main agenda be like we want to protect, we want reaction, and then at the end remove this. Okay, it's not like that. This is not bearable. Okay, it's easy to remove. So add some base, as I already told you, base is the most common one. Remove this. Ma'am, reaction, how the reaction is also simple. You know how the reaction is going on, which simply combine here. This is how the group leave. Okay, so what we are getting now, that the thing which is protecting now become a acid. Okay, anti-protection. So NH2 and NO2. So see, this is how smartly we are getting 90% yield. So it's 90% and 10%. It's one of the famous exception of the chemistry. Be noted. Okay, why? So in this case, there's a two-pointer rule. Okay, the problem solved met para is maximum, but still, it's a large group now. It is being like a bulky group. So the problem is what? Hindrance. So still, meta is not sorry, what is this? Ortho is not manageable. Okay, rule, because now hindrance come. So the one problem solved, that is para become major. Meta is omitted now because we don't want meta, because you know we are using a plus M group and we are getting meta. So it's different thing. We are not observing these things in a laboratory. Okay, it's sometime very difficult to handle all these things. So that's why we're avoiding the use of these kind of reaction. Okay, now let me know still any problem, Arul. Okay, this is the only important point in this part. Okay, exception you can say, or important you can say, or most commonly asked point you can say. Okay. Yes, please. This is all for the class. Okay. HNO3 as well. No. Listen, my point, Arul. That we are dealing with the nitration. Okay. And in a nitration, the reagent is what? HNO3 plus H2SO4. Okay. Here, H2SO4 is, here we have to follow the leveling effect. I guess I already told you in 11th class what is the meaning of leveling effect. If some strong acid is already present here, so the second acid is being like a base. Okay. Then this is taken this hydrogen from here. It means this become NO2 and water and HSO4 negative generated here. Okay, if you remember the previous classes generation of electrophile. Okay, so this is the same, the single line reagent. So it's not like H2SO4 working separately, it's not like HNO working separately. Main point, both are acid, both combined with aniline, both can do the reaction. Okay, this is just a reason for the nitration. Is this point clear now, Arul? It's be like, let's suppose I'm going, I'm explaining the bromination. There I'm using Lewis acid. You know what was the main point for electrophilic reaction is generation of electrophile. How to generate the electrophile? By using Lewis acid. But Lewis acid is a weak acid. HNO is automatically strong acid, so we can't use weak Lewis acid. We have to use strong acid, and that is only present in laboratories. That's just so for. Okay, Rul? We already covered all these points in the basic 11th class, or I guess in the alkyl part, I explain all these things if you remember. Okay, so that's it. I guess so much time done. Any more problem, please ask. Now I'm going to take the classes continuously. No Sunday, no. Okay, no leave. Hardly it will take 6 to 7 classes. Okay, for the completion of syllabus. And again, I know I was busy. Okay, it's my problem. But now I'm going to take the class continuously. Okay. Thank you so much, everyone, for joining the class. And if you're having problem, please ask. I'm waiting if you're having. Okay, then thank you so much. Thank you so much for joining the class. Okay. Thank you and be on time. Of course, you can ask. If I have a time, I will explain. Just post me on, group. There I'll explain, okay? Because in organic, so I will explain there, okay, Shiva? Let's end the class. Please connect me separately, okay? Shiva, thank you. Thank you so much, everyone. Thank you so much for the class, for attending the class. Thank you. Have a nice day.